What's up guys, welcome to this lesson where I'll be going over differentiation to find the equation of tangents and the normal. I've got two exam questions that I've got planned for you, so I'll see you after that intro. So before we begin, let's just draw an illustration of what it is that we are finding. So this is a function, a curve, and if you take any point and you were to draw a tangent to this curve, so something like that. Now the equation of this tangent will be the equation of a straight line, which is y is equal to mx plus c. Now, what's significant is the gradient of the tangent, i.e. the value of m here, is the same as the gradient of the curve at that point, that particular point, and usually you'll be given this point. So the tangent and the curve, they share the same gradient. As for the normal, and the normal is the line that is perpendicular to the tangent, creating this right angle, well, the equation of the normal will also be in the form y is equal to mx plus c. However, as we know, the normal's gradient would be the negative reciprocal of the tangent's gradient. So if the tangent's gradient is m, it's going to be minus 1 over m x plus c. So this is essentially what we are going to be doing. And like I've said, I've got two questions which I will be doing with you to show you this. So let's go. So the first question that I have is to find the equation of the tangent to the curve y is equal to 8 plus 2x minus x squared at the point 2, 8. So we are going to be finding the equation of our tangent. So we can differentiate this to find our gradient of the curve. So dy over dx would be 8 disappears, so the 2x becomes just 2, and the 2 drops down here, giving you minus 2x. So this form here will tell us the gradient of our curve wherever we want it. And where do we want it? We want it at the point 2, 8. So we can substitute the x coordinate, which is 2, and we get, so sub x equals 2 in here, we get dy over dx is equal to 2 minus 2 times 2, and that gives us 2 minus 4, which is minus 2. So our gradient of our tangent is also minus 2, because as I said earlier, they share the same gradient at a particular point, the curve and the tangent. So what do we have so far? We know that the equation of our tangent is y is equal to minus 2x plus c. And we can find that c value now by subbing in the full x and the y coordinate in here. So 8 is equal to minus 2 times by 2 plus c, and that's 8 is equal to minus 4 plus c. Take the 4 to the other side, we get c is equal to 12. So our answer is y is equal to minus 2x plus 12. Now that's in the form y equals mx plus c, but the A-level also allows you to use the formula y minus y1 mx minus x1. So I'm just going to quickly show you what that would have been in that form. So when you got your gradient, all you have to now do is do y minus the 8, which is our coordinate. Remember, we're using 2, 8 here, is equal to m, which is minus 2, our gradient, and x minus 2. So this is also another form of our equation of the tangent. Let's now move on to finding the equation of the normal. Let's have a read of this one. Find the equation of the normal to the curve and the function is given to us at the point 4, 4. So like before, we'll start off by differentiating this. So dy over dx, what do we get? Let's do that. Now we've got to be very careful because we've got lots of indices which are fractions which will come and multiply here, and then we also have to take 1 away from them, the powers individually. So 3 over 2, so that's 3 up here, 2 will multiply here, so that becomes 3 over 12, which simplifies to 1 over 4x, and then we'll take 1 away from the power, giving us a half. And then we drop this power down, so plus a half x, and the power would take 1 away, giving us minus a half. Over into this one, first of all, the sign will become a negative, and the 1 and the 4 would be 4 over 6, which simplifies to 2 over 3, which is x, and then take away 1 of the power, so 3 over 2. So this is our differentiation. Now the next step is to sub our x coordinate in here. So just to recap or go back to what we are doing here, by us substituting the value of x will give us the gradient of the curve and therefore also the gradient of the tangent because they share it. However, it won't give us the gradient that we are looking for, which is the gradient of the normal, which we will have to do the negative reciprocal of. So we will still do this by substituting x in, but then we'll have to do the negative reciprocal afterwards. So I will substitute x is equal to 4 into this equation. Before I do that, I'm going to use a non-calculator technique to do this. So I'm going to rewrite this. So I'm going to rewrite dy over dx in the following way, where I can substitute values in. Although you can just put it all into your calculator. So I'm going to have 1 over 4 root x, and then here I'm going to have 1 over 2 root x minus 2 over 3 root x to the power of 3. So now I can substitute my x coordinate in here. So I'll have 1 over 4 root 4 plus 1 over 2 root 4 minus 2 over 3 root 4 cubed. So what do I get out of this? I get a 2 here, so 2 times a quarter, which is 2 over 4, so therefore I get a half. From here, that's 2, so 2 times 2 is 4, so I get 1 over 4. From here, I get, let's start with this, so that gives us 2 root of 4, so 2 cubed is 8, 8 times 3 is 24, so 2 over 24, which we can actually simplify to 1 over 12, so therefore 1 over 12. I've got this fraction plus this fraction plus this fraction. I can make the denominators the same. All of them, I give them a common denominator of 12. So to get this to become a 12, I times it by 6. So 6 over 12 here. To get this to become a 12, I times by 3. So 3 over 12 and 1 over 12 stays as it is. Take away the numerator, so 6 plus 3 is 9. 9 take away 1 is 8, so 8 over 12, which simplifies by dividing by 4, so therefore I get 2 over 3. So my gradient is 2 over 3. However, this is the gradient of the tangent. The gradient of the normal is going to be the negative reciprocal. So the gradient I am looking for, m2, is going to be minus 1 over 2 over 3, which simplifies 2 minus 3 over 2. So this is the gradient of my normal. Now, once again, I can write it into the form y is equal to minus 3 over 2x plus c. And I can find my c value by substituting my x and my y coordinate from here, or I can use the y minus y1 formula. So the y minus y1 formula is much more simple and requires less calculation. So let's just use that for now. So it's going to be y minus 4 is equal to minus 3 over 2 is our gradient, x minus 4 as well. And this is the equation of my normal. Hope you enjoyed this lesson. If you do need to go back over basic differentiation, do check out the video on introduction to differentiation. Comment in the comment section below if there's anything that you want to see us cover, and I'll see you in the next lesson. Bye for now.